Good morning, everyone. Welcome to the Functional Food Center's 28th International Conference, which is scheduled on August 28-29, 2020. This year's conference is entitled Functional and Healthy Foods for Longevity, Bioactive Compounds, and Biomarkers in Age-Related Diseases. As you may already know, I am Dr. Danik Martirosyan, President of Functional Food Center and main organizer of conferences in the series of functional foods for chronic diseases since 2004. Just to know that Functional Food Center working in this scientific field since 1998, and we were able to organize 28 international conferences in the best universities in United States, Japan, and Germany. We already published 40 books, including 8 textbooks, and we have 2 academic journals, peer-reviewed journals, Functional Food in Health and Disease, and Bioactive Compounds in Health and Disease. I would like to say many thanks to our organizing committee members. Without them, it would be very difficult to organize this conference. And among them, I would like to mention just a few of them who will also lecture today or tomorrow. Dr. Amrenda Ajay, PhD at Harvard Medical School in Boston, Massachusetts. Dr. Uma Naidu, medical doctor at Massachusetts General Hospital. Dr. Debasis Bakchi, PhD professor from Houston College of Pharmacy at Houston, Texas. And Dr. Amaya Irondo Dehond, PhD at the Institute of SEAL in Madrid, Spain. And I would like to say special thanks to keynote speakers, Functional Food Center team members, and conference attendees. At this conference, we have 38 speakers. Among them, I would like to mention especially to our keynote speakers we have chosen. First keynote speaker is William Lee, medical doctor from Angiogenesis Foundation in Cambridge, Massachusetts. He will be presenting on food as medicine in the COVID era, nutrition strategies for prevention, intervention, and long-term recovery. Dr. Lee's main research interest is chronic and viral diseases related to the healthy and functional foods. And second, the keynote speaker is Alexander Hasberger. He is a PhD professor from the University of Vienna in Vienna, Austria. Dr. Hasberger will be presenting on fasting and individualized bioactive food ingredients, improved GI microbiota, and epigenetic regulation of healthy aging. His main interest is aging, and he is working in this area more than 30 years. Thanks to Functional Foods conference team members also who are helping me daily to continue these excellent conferences on functional food science related topics. And finally, thanks to all conference attendees. It is a great pleasure to announce that we have 3,980 registered attendees at this year from more than 100 countries. And finally, before we will start scientific sessions, I would like to remind you Functional Food Center's official definition of functional food, which is extremely important for everyone who is attending this conference and sure for scientists working in this area and governmental agencies. Functional foods are natural or processed foods that contain biologically active compounds, which in defined, effective, and non-toxic amounts provide clinically proven and documented health benefits, utilizing by specific biomarkers for health maintenance, for the prevention, management, or treatment of chronic diseases, or viral diseases, or its symptoms. Now, we can move to the scientific sessions. Thank you.
found when you compared COVID-19 is that you had this sprouting angiogenesis way higher in orange, way higher than in H1N1 in flu. So this is not like influenza A. A normal lung has none. When we compared it with sprouting, there wasn't much sprouting, but there was a lot of this emergency angiogenesis taking place. And we actually correlated the severity and the steepness of this intussusceptive angiogenesis. That's what you call the splitting of the blood vessels, as an emergency kind of red alert, sending out for the Coast Guard to try to rescue drowning sailors with the length of hospital time. The longer you're in a hospital, the more steep you see this rescue effort. The rescue never comes, and you barely see it. Actually declines, in fact, with H1N1 and not present in all a normal lung. Now, this is also for sprouting. You see a little bit of sprouting, but nothing like intussusception. So this is also the lung stuck, the vasculature stuck in an emergency state with no rescue. Think about being stuck in a house with a fire that's starting in your kitchen. So you're just trying to cover up with the smoke, and now the flames spread and it gets bigger and bigger and bigger, and then nobody's coming to rescue you. There's no windows to open. This is what we think is actually happening. And we actually did gene analysis to compare COVID-19 with H1N1, and you can see there's characteristics of genes with COVID-19 that are not found in H1N1 pneumonia or infection. And of course, in the center are the overlapping genes, which are of course interesting and important. But even more interesting are the fact that some of the genes are upregulated and some of the genes are downregulated. In the classic cytokine storm, you have massive sort of unrestricted upregulation of a large number of inflammatory genes. And we're seeing, and we're just beginning to dissect apart what is the pattern of gene expression in COVID-19. So what I hope I showed you is that COVID-19 is in fact a vascular disease as well as a respiratory disease. And we need to shift our focus from a prevention, treatment, and long-term management of this disease beyond the lung. Now, I want to share with you something interesting. As you may know, one of the first cardinal signs of COVID-19 infection is a loss of smell. That's called anosmia in the medical literature. And we didn't really understand what was actually happening. Why would you lose your sense of smell? Now, obviously, if you get a bad cold or a flu, sometimes you would just lose your sense of smell naturally. But there's something else unique going on with COVID-19. In fact, this was the group at Harvard that actually did a deep dive by looking into the olfactory system and looking at what the virus is actually doing. And these are the cell types of the olfactory system. The pericyte and the endothelial cell are the vascular cells. The pericyte's the sort of the muscular wall outside of the blood vessel, and the endothelial cells inside the lining of the blood vessel. Together, these comprise it. And so remember I told you that the coronavirus, this SARS-CoV-2, binds to human cells by looking for its spike proteins, looking for the ACE2 receptor. So look at what this group found, that if you take a look at the cells in the olfactory system that express the ACE2 receptor, it is, in fact, the vascular endothelial cell and the pericytes. And so not surprising.
Importantly, the virus may multiply in the gut and may reach other organs from there, including the lung, as you can see here, and the brain, through the gut-lung axis and the brain-gut axis. If the virus is able to multiply in the gut, this is due to the fact that the receptors of SARS-CoV-2, abbreviated ACE2, from angiotensin converting enzyme type 2, we have already talked about this receptor, are expressed in the gut mucosa. And also, very interesting from my point of view, is the fact that they can be also expressed, they are expressed in the enteric neurons. So you see here the mucosa of the gut and the enteric neurons of which reside in the intestine and also from the gut. Apart from being the receptor for SARS-CoV-2 and SARS-CoV, ACE2 is an important protective protein for the cardiovascular system. We have already discussed about this. And actually also for all the different tissues and organs where it is expressed. In the gut in particular, ACE2 reduces intestinal inflammation and fibrosis. In addition, mucosal ACE2 facilitates the absorption of neutral amino acids, particularly tryptophan, which is important for the synthesis of antimicrobial peptides, of vitamin B3, serotonin, and melatonin. As we know, As a consequence of cell infection, ACE2 is internalized and its protective function is lost. ACE2 downregulation from the gut mucosa leads to intestinal inflammation, dysbiosis, diarrhea, and may lead to a pellagra-like syndrome due to vitamin B3 deficit with skin and neurologic alterations, as well as depressive-like symptoms and altered sleep due to serotonin and melatonin deficit, respectively.
Copper, the recommended daily allowance is 900 micrograms. It's present in beef liver, oysters, chocolate, potatoes, and mushrooms. And it's implicated in the accumulation of phagolysosomes to combat infection. It's important for the antimicrobial properties. It maintains intracellular antioxidant balance, and it's a key component in the differentiation and proliferation of T cells. Regarding iron, the recommended daily allowance is between 8 and 18 milligrams, and we can find it in oysters, white beans, chocolate, beef liver, and lentils. It's involved in the differentiation and growth of the epithelial tissue. It forms highly toxic compounds that kill bacteria by neutrophils. It's a component of critical enzymes for immune cells functioning. It has a role in interferon gamma production. It regulates cytokine production and action, and it's important for the differentiation and proliferation of T cells. Regarding zinc, the recommended amount is between 8 and 11 milligrams for a female and male, and it's present in oysters, beef chuck, crab, beef patty, and lobster. And it's important for the maintenance of the skin integrity and the mucosal membrane, also for the maintenance of NK cell cytotoxic activity. It improves phagocytic capacity of monocytes. It's involved in complement activity and in interferon gamma production. It has anti-inflammatory and anti-antioxidant properties. It's involved in the proliferation of cytotoxic T cells and in IgA production. It has been reported that the combination of zinc and pyricyone has, at low concentration, inhibits the replication of SARS coronavirus. But further studies are needed to prove the efficacy of zinc supplementation, but it should also be considered to fight this new SARS-CoV-2 that we're suffering. Regarding selenium, we can find this micronutrient in Brazil nuts, tuna, halibut, sardines, and ham, and the recommended amount is 55 micrograms. It's important for the antioxidant host defense system. It increases interferon gamma production. It's involved in redox regulation. It's important for the differentiation and proliferation of cytotoxic T cells, and it maintains antibody levels.
The last risk that we've identified involves race. And this slide is specific to the United States. In the United States, Black and Hispanic individuals are most affected by COVID-19 mortality proportional to the population size. So this data is going to show for New York City, but similar trends have been seen in most major cities around the US. And what it shows us is that proportional to their population percentage, which is shown in blue, the COVID-19 fatalities percentage is much higher. So whether that means that these populations are getting more likely to even get the virus, or they're more likely to die from the virus because their situation exacerbates before they're even allowed medical care. And then you can see for Asian and white populations, it's actually the opposite effect. Other includes other populations, including Arabic and Native American populations. So next, we're kind of going to be talking about the accessibility for nutrition and what that even has to do with COVID-19. So if we look at the few of the different risk factors that we've identified, starting with age, as you get older, you might be living in a group residence, so a nursing home or memory care, retirement community. And a lot of these places have high volume meal preparation. So your meals are all going to be prepared in a commercial kitchen, and everyone's going to have the same meal. So it's not specified to your own needs in terms of health. And next, we have the urban risk factor. So a lot of urban communities in the United States have a problem called food desert. which means they are at a very increased distance from farms and gardens with fresh harvests. This means they can't really go to get vegetables and fruits, and rather they have to depend on more processed foods or packaged foods or fast foods.
Structure. And in the structure, the lipid part of the membrane is actually the matrix of the membrane, and it's important for the electrical properties of the membrane in forming a barrier across the membrane, in particular the intermitochondrial membrane, where this barrier is very important in the production of ATP. And essentially, the electron transport chain is a proton pump, and those protons are flowed back across the intermembrane to produce ATP. But if there's leakage or damage to the membrane, which occurs during aging and during disease processes, this transmembrane potential can't be maintained. This is primarily due in aging to an increase in reactive oxygen species and a decrease in the antioxidant defenses, which are normally there to protect us against this. And these free radical oxidants damage particularly the membrane glycerophospholipids that form the matrix of the membrane. So we have to remember that. The mitochondria are involved in a variety of different ways in cellular health. In addition to their ATP production, they're involved in lipid metabolism and calcium homeostasis and a number of other properties, which I won't go into, but they're, of course, an integral part of our health system. And when we become sick, in general, there's loss of mitochondrial function. And in fact, mitochondrial dysfunction is a characteristic of essentially all chronic diseases. So we know that this is an important aspect, not only in fatigue, but in other signs and symptoms involved in chronic illnesses. So mitochondrial dysfunction and disease turns out to be very important, and entire meetings have been focused on mitochondria in medicine and how mitochondrial nutrition can improve mitochondrial function. And that's basically
some way. And this is a place where nutrition can be an excellent intervention as well. In terms of the gut microbiome and its impact in mental health, what I usually share with individuals is explain the gut-brain connection, explain that, basically how our organs form from an embryo, from the morula in the embryo to the development of the different organs. The gut and brain are uniquely from the same cells. And then the vagus nerve connects both organs, and I call it a two-way superhighway because there's an ongoing reaction between these two organ systems, with people very frequently, as you know in this audience, calling the gut the second brain. And in mental health, this becomes quite significant, especially so in terms of what we eat, because more than 90% of the serotonin receptors are located in the gut. And dysbiosis is so easily set up in terms of the foods that we eat causing inflammation. And studies have also shown that things like probiotics were effective in lowering anxiety and depressive symptoms, similar to traditional prescription medications. So we do know that there's a significant impact that the microbiome plays. So this brings me to the point that much of the interventions in nutrition and mental health have to be personalized because we have a mostly unique microbiome. And one of the things that I will say is that I recently treated a mother and daughter who had the same who ate the same healthy food and had a completely opposite reaction. And I think what was fascinating is that I had not seen that as often, and I think it really again speaks to how we have to personalize the interventions with the individuals that we are treating in this area. My approach in mental health is holistic, integrated, and functional, meaning that I always look for an underlying root cause. And I have had examples of individuals, for example, who present with a range of mental health symptoms and are referred to me by another specialist, but in fact, as you take and unpack the information, actually have gut dysbiosis, which has led to symptoms such as anxiety and panic. So some of the background in building up to foods and the interventions around cognition and aging include understanding some of the foundational studies on nutrients. And some of the background data is, people tend to think of nutritional psychiatry as a very nascent to new field. The truth is that we've been studying individual nutrients for years and for decades. Things like folate, omega-3 fatty acids, vitamin D, and magnesium have been linked to mental health conditions for a very long time. And these studies have been well known, including the fact that in the 1990s, specific study, this particular one was one of the earlier studies, linked nutrition to depression. And later on, also in the 1990s, omega-3 fatty acids were tested in bipolar disorder and found to be effective. Following on such studies, other diagnoses in mental health were also studied. Again, the protocols and discussions that I have with patients are really around a whole food healthy diet, and that being one of the pillars of mental health treatment that I do believe is helpful in nutrition and mental health. This study was particularly helpful because it helped us identify that there are certain things that we need to pay attention to in terms of nutrition interventions in psychiatry. With the immune system, we also know that a very large component of the immune system is housed in the gut. So how we eat is even more important. It is especially important during times of a pandemic that we pay attention to how we're eating to not only build up and fortify immune system, but so that we are not then prone to illness.
Possible. But obviously you saw that $100 billion number there. That's an annual number that we spend in the United States every single year on these kinds of products to help us feel better. So obviously there's a big problem there. If we look at the new science around the gut-brain axis, we see that there are some very effective, well, very, very tantalizing, right? The data is compelling that if we do something in the gut, if we modulate the microbiome, if we improve gut integrity, we can get a psychological outcome. We can reduce depression indexes. We can reduce anxiety. We can reduce stress. And there's very, very good rodent studies, but there are also very, very good human studies to show us that this mind-gut connection is very robust. It's very modifiable, and it results in very meaningful changes for people. And I'm not going to spend too much time into the nitty-gritty of the microbiome. That's a whole separate talk. But suffice to say that the microbiome has a big impact, maybe the biggest impact on our overall mental wellness, because 90% of the serotonin in our body is made in the gut. 70% of the dopamine is made in the gut. Most of our norepinephrine, most of our GABA, most of these neurotransmitters are derived in the gut. And that's not to say, when I say that, sometimes people get the mistaken notion that this serotonin, 90% of the serotonin in the body that's microbiome derived, is going to somehow leak out of the gut and go into the systemic circulation and then leak into the brain, and then we're going to be happier. It doesn't work that way. Part of what happens is transfer of signaling. So that higher serotonin level, we know that it helps people feel better. People have lower depression indices, but that signal might be traveling through the immune system. It might be traveling through the inflammatory cascade. It might be. We're still trying to tease out the mechanisms here. But somebody was talking about this earlier in the day, the fact that our bacterial genome far outnumbers our human genome. And it really is the interplay between what's happening at the microbiome level and what's happening at the human genome level that results in an outcome of epigenetic expression that leads to a health outcome. So we're trying to take that in the right direction, if you will, with the interventions that we're developing. So again, just because of the limited time that I have, the bottom line here is that if you're in balance with your microbiome, you tend to feel good. If you're out of balance, you tend to not feel good. And when we measure this psychologically, when we use psychological metrics like profile of mood states and different stress surveys, we can see that people are more tired, they're more irritable, they're more angry, they have more brain fog and that's associated with a variety of different microbiome disruptions. So it leads us to this idea of, can we modulate the microbiome, get signals to come from the gut to the brain across this axis and help people feel better. So a lot of times,
before even we have shown that catechins affect the epigenetic machinery, especially DNA methyltransferases here. And we have seen the consequences on the methylation of the DNA repair enzyme MLH1, also in comparison also to vitamin E. We know now very well that different SIRT enzymes specifically regulate effects like epigenetics, metabolic pathways, autophagy, DNA repair, and the circadian clock. So the SIRT they are working and they are changing epigenetic mechanisms like the histones and the senescence and the DNA repair mechanisms. Both caloric restrictions and polyphenols affect the SIRT, as well as PGC1 alpha. And especially the modulation of SIRTs and the consequences in vitro and in vivo is in the center of our interest. But again, we need to have an eye on the microbiome, because caloric restriction as well as polyphenols affect aging mechanisms, additionally involving changes in the gut microbiota. For instance, polyphenols, via their metabolites, which are often produced in the gut, they affect microbiota. For instance, here, this misbalanced microbiota here, and affect the production of short-chain fatty acids like butyrate here. So what happens here is that caloric restriction and polyphenols and their metabolites affect epigenetic mechanisms via affecting short-chain fatty acids. Since a few years, the idea of senolysis, the eradication of senescent cells from one or more tissues, became really vibrant and of interest, and also a lot of news were in the papers and so. And there were also a lot of names of drugs dropped, but also plant ingredients which have the potential of senolysis. And this is clearly of a big major health interest, but also, of course, a big economic interest.
And we test the effect of the olive oil extract at long and short term. So at long term, we did the calibration experiment of calcium, and we found that the olive oil extract slightly but significantly increased the intracellular calcium level, and in some cell type, a slight increase of the calcium level may exert a protective effect. And this increase was abolished when the cells were pretreated with a specific, selective calcium sensing receptor blocker, which is called MPS 2143, indicating that this increase is associated, is due to the calcium sensing receptor stimulation. Then we found that short-term treatment with the olive oil extract also results in a significant increase of intracellular calcium level, which again was abolished when the cells were pretreated with the calcium sensing receptor antagonist, the MPS 2143. So to correlate this observation with the aquaporin 2, and in particular the aquaporin 2 function, we measured the water transport again in the presence of the calcium sensing receptor antagonist. So what we found, and as I showed before, that vasopressin stimulation increased water absorption. and the treatment with the holy leaf extract counteract and block the action of vasopressin. However, when the cells were pretreated with the blocker of the calcium sensing receptor, the OLE failed in blocking the action of the vasopressin hormone, indicating that this impairment under this condition is associated with the stimulation of the calcium sensing receptor. So we've also found that the calcium sensing receptor stimulation can downregulate aquaporin 2 expression through the formation of a specific microRNA. And in particular, we demonstrate that the miR-137 is associated with a downregulation of aquaporin 2 expression. So we then perform in vivo experiments, and several rats were injected for 3 days, 1 per day, with the olive leaf extract. Then the kidney were removed, and we measure by, we perform real time and also Western blotting analysis. Here, on the right in this histogram, you can see that the olive leaf extract increase the abundance of this microRNA 137, and this increase is associated and correlated with a significant downregulation of the aquaporin 2 mRNA.
In a normal situation, insulin fits into the insulin receptor on the cell, and when that happens, that opens the door to allow the cell to allow glucose into the cell. So that's the key, I call it the glucose key inside the cell is needed in order to let glucose into the cell where it can make ATP. Well, what happens is when you glycate insulin, as you do, and you glycate the insulin receptor, basically, they don't recognize each other anymore. The key does not fit into the lock. And as a result, you end up with high levels of glucose in the bloodstream, and that signals the pancreas, make more insulin, but it doesn't do any good because of this insulin resistance where your receptor and your insulin get glycated and they don't work properly. And when we're all born, we have enough insulin to last us for a lifetime. But if we have insulin resistance, the pancreas cannot keep up with it. So chronic hyperglycemia, high blood sugar levels, means you can't make enough insulin. And eventually, we may end up, unfortunately, have to take insulin shots in an attempt to control glucose. And once you start on insulin, you're on a one-way street. You end up needing more and more insulin because your insulin resistance is poor. And eventually, you just cannot take enough insulin. Well, I'm happy to announce that we have a natural nutritional supplement called Lysulin, and its target is protein glycation. And all 3 ingredients have been shown to lower blood glucose levels. That's a symptom of diabetes. But in addition, Lysulin attacks the cause of insulin resistance and diabetes, which is protein glycation. And as I'll show you, the lysine in Lysulin can stop protein glycation and the formation of these advanced glycation end products. And all the ingredients are generally recognized as safe, so there are minimal side effects with Lysulin, unlike prescription drugs. So this is a slide that shows what happens. So you have a normal protein here in blue, and when glucose is present, that glucose reacts with that protein, altering its structure. And this can then lead to the disease complications. However, if you have Lysulin present, the lysine in Lysulin now reacts with glucose. So the glucose reacts with the lysine instead of the protein, and that forms glycated lysine, a small molecule, and that's safely excreted in the urine. And therefore, there's no disease complications. So Lysulin sort of acts like a sponge to soak up the glucose that's causing all the problems.
So let me give you a little history. So blackcurrant, which is Ribes nigrum, is native to Central and Eastern Europe and Northern Asia. And it is a berry fruit with health benefits that include reduced risk of cardiovascular disease, suppression of obesity and diabetes, and improved bone and muscle mass. So when it became banned in 1911 from the United States, actually many farmers actually felt the crunch, especially because the effect on the pine industry due to the vector white pine rust. So black currants contain 4 major anthocyanins: delphinidin 3-O-glucoside, delphinidin 3-O-rutinoside, cyanidide, 3-O-glucoside, cyanidide, 3-O-rutinoside. And black currants also contain numerous vitamins and minerals, as well as other phytochemicals, and they contribute to its medicinal properties. There are high levels of minerals, including potassium.
And then continuing functional food processes that are already in place. In Europe, there's FUFOS, so the European Commission Concerted Action on Functional Food Science developed the scientific concepts of functional food, outlining how functional foods must beneficially affect their target functions in a testable way, and placing heavy emphasis on biomarkers that are measurable. And there is a really intense importance that is placed in clinical human trials for testing functional foods, as well as a need to engage in heavily interdisciplinary research in order to best utilize the field of functional food science. So there are 2 governmentally recognized processes on functional food science and functional food production, namely FOSHU and FUFOS in Japan and Europe, respectively. And these served as bases for our outline, and we think that they can serve as bases for an FDA or otherwise official recognition and establishment of functional food science.
Now, here we talk about dioxin, TCDD. In Japan, USA, and EU, it is very toxic, highly toxic, and poisonous. But you can see here that there is no classification in the lower level, but it is toxic almost at the same par, that you should not use it in these foods anyway as a contaminant. And these are all the products: dioxin, parathion, nicotine, caffeine. But caffeine you can use up to certain dose. Sodium nitrite in the fertilizer, paracetamol, so there are the labels. Now, acute versus chronic toxicity, as you know, you can see an effect within 24 hours, but chronic, why you need to do chronic toxicity? Because you can see the delayed effect. That's why it is important.